Good afternoon, student. This is the lecture number 9 of unit number 2, that is Introduction to Instrument Characteristics. Today we are going to study the static characteristics of the various instruments. Okay. In the previous lecture we have studied what is characteristics, then what is static characteristics, what is dynamic characteristics, then the different types of characteristics such as range and span, then accuracy, error, correlation, then calibration. These three static characteristics we have studied in the last lecture with the help of example such as a spring balance measuring instrument. Okay. Then today we are interested to study the hysteresis, fourth static characteristics of the instrument, that is hysteresis. Before going to the definition of the hysteresis, just observe the graph shown on the slide. Okay. In the first graph, on x-axis there is input and on y-axis there is output. Okay. There is one curve which is started from the origin on the upward direction, that is loading, and from the end point of the loading curve there is a unloading, showing the curve which is lowering down and intersect at the y-axis. Okay. So what it indicates, that we will have to understand first. Okay. Now suppose we have considered one instrument. Okay. Now we have considered the spring balance, or we may call it as a weighing machine. Okay. In the weighing machine, gradually we are increasing the load from 1 kg, 2 kg, 3 kg. Okay. And we will have to observe simultaneously the magnitude shown on the display of the digital weighing machine. Okay. So as we have given the input of 1 kg weight on the platform of the digital weighing machine. Okay. So it will show certain reading. Before that there is no input, it will show the zero output. Okay. Means in the starting condition, if we have not applied any load on the platform of the weighing machine, it will show the zero output on the display. Okay. So that's why we will get the first point as a origin. Okay. Then gradually we are increasing the input. So we have placed the 1 kg weight on the platform, so it will show some reading on the display panel. Means that will the output. Means whatever the weight we are placing on the platform of the weighing machine, that is input, and whatever the display panel showing the reading, that is nothing but the output. So for 1 kg weight we will get the certain output. It may be 1 kg, it may be a slightly greater than 1 kg or slightly lower than 1 kg or equal to 1 kg. Okay. So depending upon the accuracy of that instrument, it will give the output on the display panel. Okay. So we will consider the for 1 kg weight it will give 1 kg output. So we will mark that point on the graph. Then again we will place the 2 kg weight on the platform. Then again the output of the display panel will show the it may be 2 kg, greater than 2 kg or less than 2 kg. So that point we will mark on the graph. Means on x-axis there is a 2 kg and y-axis there is also 2 kg. Okay. Then again we will increase the weight by 1 kg, that it will be a 3 kg. So we will check the output shown by the display, and that point we will mark on the graph. Okay. Likewise, from origin up to the loading point, means from origin up to this point we will reach here by increasing gradually the weight as a input, and by seeing the reading displayed over the input. Okay. Then this is the loading condition, means we are increasing the weight gradually. Now we are interested to decrease the weight one by one. Suppose we have reached up to 10 kg, just remove the 1 kg weight. We will have to check that display panel will be showing the same point or not. Okay, so it will give somewhere uh, in this direction. Okay, so here we will get the point. Then again we are removing the 1 kg weight. Then the 8 kg weight will be present on the platform of the weighing machine. Okay, then we will check the output reading. So somewhere it will giving the point here. Then again we are removing the weight. Now the 7 kg weight will remain on the platform, so somewhere we will get the point here. Okay, and so on up to 1 kg will remain on the platform, so it will show some reading which will be intersecting at the y-axis, this point. Okay, means what we have observed from that graph, we are increasing the weight gradually. Okay, by 1 kg, 2 kg, 3 kg, 4 kg. Means while loading condition, the instrument showing the same reading as like that of the we are placing the input. Means it will be showing the same output as like that of the input. But while unloading, means we are removing the weight gradually. Means from 10 kg to we are keeping 9 kg, from 9 kg to we are keeping 8 kg, likewise up to 2 and 1. Okay, but the output reading shown by the instrument, that is different from the whatever the reading shown by the instrument, output reading shown by the instrument in case of the uploading condition. Okay, so that difference in the unloading and loading condition, means loading and unloading condition, means that is the difference between the reading shown by the instrument in case of the loading and unloading condition. That is nothing but the hysteresis of the instrument. Okay, so now we will go through the definition. Means I think you have got whatever the explanation I have given to you. इज इट? मला असं वाटते सर्वांना समजलं असेल की जेव्हा आपण ग्रॅज्युअली 1 बाय 1 वेट प्लेस करतो प्लॅटफॉर्मवर वेइंग मशीनच्या, तर प्लॅटफॉर्म सेम रीडिंग डिस्प्ले करते ॲज जेवढं वेट आपण प्लेस केलं तेवढं, बरोबर आहे. परंतु जेव्हा आपण अनलोडिंग करतो तेव्हा काय होते, त्यामध्ये काही प्रमाणात चेंज होते. ओके, मीन्स इट इज इरिव्हर्सिबल, नॉट रिव्हर्सिबल. ओके, सो see here, the magnitude of output for a given input depends upon the direction of change in input. Means magnitude of what? Output for a given input, means whatever the magnitude of output shown by the instrument, that is given by the input, and depends upon what? Depends upon the direction of change in input. Okay, by which rate we are changing the input. Okay, whether the input signal is ascending, it will be loading, or descending, that is unloading. This dependence of output upon previous input is called as hysteresis. The dependence of what? Dependence of output upon previous input is called as hysteresis. It is one of the definition. Okay, second, the hysteresis is the maximum difference for the same measured quantity. हिस्टेरिसिस काय आहे? मॅक्सिमम डिफरन्स. ओके, मॅक्सिमम डिफरन्स फॉर द सेम मेजर्ड क्वांटिटी बिटवीन अपस्केल अँड डाऊनस्केल रीडिंग ड्युरिंग फुल रेंज ट्रान्सफर इन ईच डायरेक्शन. ओके, म्हणजेच काय, जी सेकंड डेफिनेशन दॅट विल बी एक्झॅक्टली मॅचिंग टू द एक्सप्लेनेशन गिवन बाय मी. ओके, हिस्टेरिसिस इज मॅक्सिमम डिफरन्स. काय आहे? मॅक्सिमम डिफरन्स आहे कशामधला? फॉर द सेम मेजर्ड क्वांटिटी between the upscale and downscale, means uploading आणि downloading, uploading and loading, or we may call it as unloading and loading मधला जो डिफरन्स आहे. ओके, डिफरन्स, मॅक्सिमम डिफरन्स फॉर द सेम मेजर्ड क्वांटिटी. मेजर्ड क्वांटिटी व्हॅरी होत आहे काय? तेच 1 kg वेट आहे, तेच 2 kg वेट आहे, तेच 3 kg वेट आहे. ओके, दॅट वेट आर नॉट चेंजिंग, but whatever the reading shown by the instrument while unloading, it is varying, okay, from the loading. Okay, means whatever the weights we have used for the loading condition, these for that purpose the instrument is showing the exact reading as that of the input signal, but while unloading the instrument will not showing the exact reading as light of the uploading. Okay, so that difference is nothing but the hysteresis. Okay, that difference is nothing but the hysteresis. Okay, then the maximum difference is frequently specified as a percentage of full scale. That maximum difference is frequently specified as a percentage of full scale. Okay, then hysteresis results from the presence of irreversible phenomena such as, now the question maybe arises that why the instrument will show that difference while unloading and loading. Okay, each and every one has that question may be in mind, why that instrument will show that difference. Okay, so that difference is only because of the mechanical friction, slack motion in bearing and gear, elastic deformation, magnetic and thermal effect, okay, and inertia of the moving part. Okay, means we know that as that we are considering the weighing machine, now we are considering some other machines which are used for the measurement purpose. In that condition there will be some rotating components will be there, so that the inertia of rotating component will be act in the means while work measuring. Then elastic deformation, then magnetic effect will be come in the scenario, thermal effect. Okay, so mechanical frictions will be there, slack of motion in the bearing. Okay, so these are the different reasons on which the hysteresis is depend. Okay, or we may call it as a, that instrument shows the different reading while loading and unloading only because of the that different reasons behind the different component present in the instrument. Okay, so hysteresis result from the presence of irreversible phenomena. Means reversible means what, ज्या रस्त्याने जात आहे त्याच रस्त्याने वापस येतो, दॅट इज नथिंग बट द रिव्हर्सिबल. ओके, ऑर वी मे कॉल इट ॲज अ, ज्या पॉईंटपासून स्टार्ट करतात त्याच पॉईंटला परत येत आहे, दॅट इज रिव्हर्सिबल. बट इन केस ऑफ दॅट हिस्टेरिसिस, द starting point is at origin and finishing point or returning point is at the intercept at the y-axis. That's why it is a irreversible phenomenon. Okay, so I think all of you have got what is hysteresis. Okay, then next parameter we will have to study, that is drift. Next parameter means what? Next static characteristics of the instrument, that is drift. Okay, so again here we can see two graphs. Okay, on x-axis there is a input and on y-axis there is a output. Okay, so on this graph two lines are shown. One is dotted line which is passing through the origin, and one is straight line which is passing through the intercept at y-axis. Okay, so what does it mean, that we will have to understand. Okay, so it is an undesired gradual departure of the instrument output over a period of time that is unrelated to change in input, operating condition or a load. An instrument is said to have no drift if it reproduces same reading at different time for same variation in the measured variables. Okay, means what? It is an undesirable, or what we can say, that it is an undesired gradual departure of the instrument output over a period of time that is unrelated to the change in input. Okay, change in input, operating condition or load. Means what? If the instrument is not showing the same reading, instrument is not showing the same reading for a different time variable. Okay, or we can say that the instrument will not showing the same reading for a given input at a different interval of time. एकच इन्स्ट्रुमेंट आहे, आपण जर सकाळी त्यावर एक नोन क्वांटिटी ऑफ वेट प्लेस केला आहे at that time the instrument will show the different reading. Suppose we have measure the same known quantity of weight at after half an hour, then it will show the different reading. Suppose we have measure the same quantity of weight after 2 hours, then the instrument will show the different reading. Means what? The instrument will give the undesirable gradual departure of the instrument output over a period of time. ओके, म्हणजेच वेगवेगळ्या टाईमला एकाच क्वांटिटीसाठी वेगवेगळं रीडिंग जेव्हा इन्स्ट्रुमेंट शो करते, दॅट इज नथिंग बट द ड्रिफ्ट. ओके, अंडरस्टूड? लिसन अगेन. इफ the instrument is showing the different output for a same input at a different time period or different time interval. Okay, so here it is an undesired gradual departure of the instrument output over a period of time that is unrelated to the change in input. Unrelated means what? We are placing the input on the platform of the weighing machine, but the instrument is showing different reading. Means unrelated to the change in input. Means जे काही known quantity आपण place केली as a input to the instrument, but the instrument is showing some other reading. Okay, after certain period of time again we have placed that same input, known input to the instrument, but the instrument is showing some other reading or other output. That is nothing but the drift. Okay, an instrument is said to have no drift. Instrument मध्ये drift नाही आहे कधी म्हणणार आपण, if it reproduces the same reading at a different time for a same variation in the measure variable. म्हणजेच काय म्हणूयात आपण, जेव्हा इन्स्ट्रुमेंट सेम रीडिंग दाखवते and instrument is saying or said to have no drift if the instrument reproduces the same reading at a different time for a same variable in a measured values. Understood? जेव्हा एखादं इन्स्ट्रुमेंट सारख्याच व्हॅल्यू दाखवते फॉर अ डिफरंट टाइम इंटरवल फॉर इनपुट. Okay, for a variable input. Okay, so that is nothing but the drift. Okay, so the second, again the question may be arise that in the graph here we can say that the zero drift. What is zero drift? That characteristics with a zero drift means what? The intercept at y-axis and the line is following the proportionality, that input is proportional to output. Okay, means it is directly proportional to the input is directly proportional to output. Means whatever the input given to the instrument, the output is again showing the same input. Okay, so that's why that input is proportional to output. But in case of the second diagram, here we can say that the input for different input, the instrument is showing the different reading. Okay, so that is nothing but the drift. Now the again question may be in your mind, how that drift occur in the instrument. Okay, so high mechanical stresses develop in some parts of the instrument and system. High mechanical stresses develop in some parts of the instrument and system, wear and tear, then mechanical vibrations, temperature changes, electric and magnetic field, thermal EMFs. Okay, means what? We know that as there is some mechanical component will be used in the instrument, so there will be some stresses will develop in the instrument and system. Okay, then the wear and tear means what? As there will be mechanism present in the assembly of the instrument, so there will be some relative motion will take place between the different components. That's why there will be wear and tear will occur because of the friction created in between the rotating components. Then mechanical vibrations because of the different matching components. Okay, the components is in contact with each other. Okay, then temperature changes. Temperature means we know that in different environmental conditions the temperature varies from time to time. In morning the temperature will be different, In afternoon there will be the different temperature, and in evening the temperature will become decreases somewhat lower than the noon session. Okay, so and at midnight the temperature will be drastically down in winter, in summer, and in rainy days. Means different in the different time interval the temperature will become changes. So because of that it will be affect the working of the instrument. Then electric and magnetic field, as there is some electrical instruments will be there. In the instrument there are primary winding, secondary winding, and when the current will pass through the instrument, some EM will be generated and magnetic will be created. So because of that also the instrument will become instrument will consist of certain amount of drift. Then thermal EMF also contribute to the drift of the instrument. Okay, so that is nothing but the related to the drift. Then for 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 understanding of the drift, I will give you one example related to the speedometer of the bike. Okay, so when we start the bike and engage the first, second, third gear respect to the speed variation of the bike, when we increases the speed with the help of accelerator on the display panel, again there are two dashboard will be there. One for the analog display, and second will be digital display. Okay, in now means advanced vehicles, that two things are available with the dashboard of the bikes. Okay, now as we increases the accelerator, the pointer of the display panel will deflect. Okay, and as well as the display panel of digital meter also shows certain reading. Now most of the time it is happen that whatever the reading shown by the digital meter will not be matches with the pointer of the display panel. Because what? Because of the different causes, as we have discussed earlier, that is wear and tear, mechanical vibration, temperature changes, electric and magnetic field. Okay, these are the different reasons. Now what will happen? Suppose that digital odometer will showing the 65 km per hour, then in that case the analog display meter pointer will show somewhat 62 or 63, or it may be lesser reading, or it may show some greater reading. So depending upon the effect or depending upon the drip, it will show some different reading. Okay, most of the persons from you have observed that whatever the example I have given to you. Okay, so that is nothing but the drift. Now next we will have to study the different types of drift. In that the classification of drift. First drift is zero drift. Second is span or sensitivity drift, and third is a zonal drift. Okay, so here other examples are also given. So that is drift occur in a resistance thermometer and thermocouples due to the contamination of a metal and a change in its atomic and metallurgical structure. That is one of the other example. Then drift occur in a flow meter. Flow meter is present in the measurement system lab. That drift occur in a flow meter due to wear and erosion of the orifice plate, nozzle or venturi meter. Drift occur in flow meter. Okay, and because of that why? That is wear and erosion of the orifice plate, nozzle or venturi meter. That is nothing but the reason of occurrence of drift in the flow meter. Okay, so classification of drift. The first we will see the zero drift. What is zero drift? That zero drift it is said if whole of instrument calibration gradually shift over by the same amount. Okay, means complete instrument is shift gradually over by some amount. In this graph we can observe here the zero drift is shown. Okay, see here, this is zero trip, means whole instrument values are shifted by a certain amount. मोस्ट ऑफ द ॲनालॉग इन्स्ट्रुमेंटमध्ये सुद्धा पाहिलं असेल की तो जो पॉइंटर आहे झिरोच्या समोरच शिफ्ट झालेला असतो. मीन्स फॉर मीन्स विदाउट गिविंग एनी इनपुट टू द इन्स्ट्रुमेंट with the help of regulator of that instrument, the pointer of the instrument is started from means after the zero mark. Okay, so that is nothing but the zero trip. Okay, so it is said to set if whole of the instrument calibration gradually shifted over by the same amount. Okay, so because of what? Due to the slippage permanent set. Okay, then next is a span or sensitivity drift. It is said to set if the calibration changes proportionally along the upward scale. Okay, means what? It is said to set if the calibration changes proportionally along the upward scale. That calibration is changed along the means upward scale beyond the zero value. Okay, then zonal drift, when a drift occurs only over a portion of the span, okay, of an instrument, it is termed as a zonal drift. Means what? Along the region of a span, an instrument shows certain reading. That is nothing but the zonal drift. Okay, so these are the different types of drift. So in the next lecture we will see what is sensitivity, what is the relation between the input signal and output signal, then deflection factor, then one numerical related to deflection factor that we will have to cover in the next lecture, that is threshold resolution, then resolution. Okay, so that is nothing but the part we have completed today. First is hysteresis and second will be drift. Okay, so whatever the doubts you will have, that we will discuss in the Google Meet. So we will stop over here. Thank you.